Today we'll discuss a brief engineering history and what subfields are associated with electrical engineering. I know we have also met these subfields in the past, but it won't harm to discuss them nevertheless. So we discuss the subfields of electrical engineering and a brief history. So what comes to mind when we are discussing electrical engineering? Most people, it might be this, and this means a power station where power is being converted from probably high voltage to another high voltage. But this is how a power station looks like. So this is one of the major fields that people know about electrical engineering. It involves generation. This is something we have said a number of times: generation and of power, then transmission of power, and then distribution of power. So I believe most of you will not forget this. So that is one of the fields of electrical engineering. The other one that is quite very significant is the one that we call electronics. So we are saying that this is another very important field. Of course, we were saying that some electrical engineers design power systems on a macroscopic level. And this is what power generation or power transmission or power distribution. It involves dealing with high voltage. But we have also seen in our class that electrical engineering also involves electronics, like this one where we are dealing with. This is called motherboard. And I know a good number of you have seen a motherboard, either that of a radio, of a phone, of a computer, and many others. So that is a branch of electrical engineering that is called electronics engineering. So it deals with the small electronics at a chip level. So that just introduces us again to electrical engineering, which we have already been introduced to. But we are actually more interested in looking at the history of electrical engineering. So to define, electrical engineering is a technical discipline that is concerned with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. It emerged as an identified activity in the latter half of 19th century, which came after the commercialization of telegraph, electric telegraph, a telephone, and electric power generation and distribution. So that is, of course, something we have seen in the past. That is how or what constitutes electrical engineering. We are always concerned either with power generation, transmission, and consumption, or communication. So as you can see, one of the earliest indicators or one of the earliest fields of electrical engineering was telegraph. Telegraph is involved purely about transmitting information. So that is one of the fields that we have seen, that two major fields of electrical engineering involve power systems, and the other major field involves communication systems or telecommunication systems. That is, so we are seeing one of the earliest of electrical engineering is telegraph. And again, telephone was also a part of that early fields that characterized electrical engineering, and also power generation and distribution. Electrical engineering, so as we have said, from the two branches two major branches that constitute electrical engineering, we have so many subfields, and that is where we want now how much we're going to be dealing a lot with today. And here they are mentioned. Electrical engineering is divided into a wide range of fields that include computer engineering, power engineering, telecommunication engineering, radio frequency engineering, signal processing engineering, instrumentation, and electronics. So what we are going to be, I should actually mention this, that at this level, you don't need to go deep into what entails, or at a very highly detailed level of what power engineering involves. But at your level, you actually need to be able to define each of those. You need to be able to tell me what is telecommunication, what is radio frequency engineering, what is signal processing engineering. And that is what we are going to be discussing today. Okay, that is a very serious requirement that we will require you at this level where we are introducing you to engineering. You should be able to now tell somebody that instrumentation deals with instruments and measurements and units. Electronics deals with chips and that microscopic level of electronics, of electrical engineering. So that is something we're going to be discussing today, and you should be able to clearly define. So these concepts like power engineering, like telecommunication engineering, among others. So that's a point that I have said. We're going to be testing you on this. So many of these disciplines overlap with other engineering branches, and we have said that, spanning a huge number of specializations, including hardware engineering, power electronics, electromagnetics and waves, microwave engineering, nanotechnology, electrochemistry, renewable energies, mechatronics, electrical materials, or material science, among others. So you can always find out more on each. And what I even advise you, beyond what I will cover today, is that the notes, because I will share these notes with you, you just need to click on the link that, you see, if I click this link, Power Engineering, it will open up a browser, and it is taking me to Wikipedia, where power engineering is defined. So I advise each one of you to do that on your own, so that anything that will become unclear after today's class, you can always find out more, because Wikipedia is a very good tool for studying and even telling you about history and about anything related to what you have asked of it. So I have left those links purposely, so that in case there is something that will be unclear as we move along, then you can be able to study on your own. So whenever you see a blue link, know that it's a link that you can study more on by just going to the internet. When you hear someone being called an engineer, the minimum qualification is that they should have a degree in electrical or electronic engineering, or even telecommunication engineering. So that is the minimum. So anybody who doesn't have a degree but has a diploma, they qualify to be called technicians or technologists, depending on the level of diploma that they have, that they hold. But anybody who, even if you are called a graduate engineer, that means at least you have graduated with a degree in electrical engineering. Now, we also say that practicing engineers, this is something I think I've said over and over again, may have a professional certification and be members of professional bodies or international standards of organizations. And we have said that some of them are, okay, in Kenya, because that is where we are, we need this just to be conversant with Kenyan system, is that we have EBK. EBK is one of the bodies that accredits professional engineers. So you can either become a graduate engineer or you can become a professional engineer. So that is one body that accredits, and that is what we are calling professional certification of an engineer. So when you are a graduate engineer, you are just allowed to work as an engineer so that you can be trained. You work as an engineer, after 3 or more years, you get some experience on having worked on real life projects that allows you to now be registered as a professional engineer. But you cannot start by becoming a professional engineer before you have started by being a graduate engineer. There's another body in Kenya that is called IEK. You can always Google that. It is a body that is a society called Institute of Engineers of Kenya. So this is K, this is E institution. So this is another body that sometimes you may not follow the route of being given professional engineer by the EBK, but there is another level of engineers that you are also registered, you can be registered by IEK. IEK is also a body that can accredit you in Kenya, and therefore you are allowed to practice as an engineer. So you have two options, either working with EBK or working with IEK. So I just try to clarify that. Two paths you can follow to become an engineer. One of them is via EBK. This is a government body mandated to license engineers. It is formed by government and it is mandated to license engineers. The IEK is an institution that is more of a society of engineers of Kenya, just as it is called. Kind of, it's a body that regulates their own. It is just like the way you can have doctors. I think we also have that with the doctors. Doctors form their own body that set up some standards for them to follow, so that anybody who is practicing as a doctor must be certified by the doctors union. So in a similar manner, in engineers, we have Institute of Electrical Engineers of Kenya that does that. It is a body that regulates, sets their own regulations and satisfies other engineers. So it is more of a professional body than a regulatory body. So that is the difference. One of them creates their own regulations. The other one is regulations are created by a government that is a government-owned body like EBK. So I hope that is clear. Internationally, there are bodies that credit engineers, and we can see a very common one that is very prominent is the one that is called Institute of Electrical and Electronics Engineers. This is a worldwide body. So anything that is happening worldwide regarding the many fields of electrical engineering is normally carried out or managed or even published at the IEEE journals. So what this does, this body is mandated with very many tasks that are kind of regulate and even lead, show direction to where the profession of the electrical engineers follow. So again, the other bodies, so I don't necessarily need to dwell there. All I am saying is that there is, for you to practice as an engineer, you need to be under some professional body or regulatory body that govern the profession of engineering. Electrical engineers work in a very wide range of industries, and the skills required are very many, or they are very variable. So, and I think we have said that in the past, you can become a power systems engineer and you know very little about communication, or you can become a communication or telecommunication engineer and you know very little about power systems. So that is what that statement says. So these fields range from circuit theory to the management skills of a project manager, and the tools and equipment that an individual engineer may need are similarly variable, ranging from a simple voltmeter to a top-end spectrum analyzer, such that even sophisticated design and manufacturing